Our speaker today is Dr. Jessica Few. So I met Jessica, well, it wasn't that long ago, was it? I met Jessica because I was her external PhD examiner along with Andy Pasilli. And I have to say, examining PhDs is always an enjoyable process, but it was particularly enjoyable in this instance because of both the nature of the work and the quality of it. Jessica's been at the UCL Energy Institute since 2016, first for a master's and then PhD. She was supervised by Cliff Errol and Michelle Shipworth. Her PhD focused on ventilation in occupied homes, and she's been particularly interested in how we can really practically measure ventilation over time, and particularly how occupants influence that ventilation, which is clearly kind of critical. As I say, she finished a PhD last year and is now working on the Smart Energy Research Lab project. And so that's collecting and analysing smart data meter and linked contextual data from, I think, 13,000 homes across the UK. And this data is being made available to other researchers. So with no further ado, I shall hand over to Jess and allow her to do her piece. Thank you.
Okay, thanks very much, Tim. Yeah, so I'm going to be talking about my PhD research, which, as we said, focused on ventilation in occupied homes. And I was kind of both looking at the kind of measurement of ventilation and also a kind of socio-technical perspective on what's going on in homes. Let's see. Oh, I can't change slides. That's good. Oh, there we go. Okay, so yes, I'm just firstly going to go over just some of the background research context, and then I'm going to talk about ventilation measurement methods and how I kind of thought about that and what I did to kind of tackle that problem. I'm going to talk about some of my technical findings in a couple of different case study buildings that I was working with, and then I'm going to talk about my socio-technical findings, and then I'll kind of draw it together into some kind of conclusions. Okay, so just some background. So probably we're all familiar with this, so I'm not going to go into it too much, but there are kind of increasing pressures to reduce air permeability in buildings to reduce the carbon emissions associated with buildings to meet our climate goals. But in order to ensure that we have adequate ventilation, which is required for good indoor air quality and occupant health, we need to make sure that there are adequate ventilation systems put in place in homes at the same time as increasing the air tightness. So approved document F sets out the domestic ventilation systems which are expected to provide adequate ventilation in homes. That's in England. So that document kind of sets out the kind of systems that you can put in place that will be assumed to ensure that there is adequate ventilation in homes. But I'd say there's been relatively little detailed research exploring the ventilation rates that are actually experienced in homes when you put those systems in place and you let real occupants live there. And there's kind of limited research on kind of how those systems are being used in practice and what ventilation rates occupants are really experiencing over time. So that's kind of the kind of background, I suppose. But the research that does exist on ADF often shows that there are discrepancies between what ADF sets out and what's actually going on, and that ventilation rates are often not as high as we might hope that they would be. Okay, so the first thing I was kind of interested in was how we can actually measure ventilation in homes. So ventilation is driven by changes in by pressure differences between indoors and outdoors, and these are caused by temperature differences and wind and mechanical fans. So all of those factors can be quite variable over time. And one of the first things I got quite interested in was this paper by Wallace et al. From 2002 from the US. And what they did was they measured ventilation in an occupied home over a year using SF6 decays. And they took kind of measurements over sort of hour-long periods over kind of this year-long period. this kind of research is really unusual. So they measured about sort of, I think, over 4,000 measurements of ventilation over the year. And they got this kind of quite big range of ventilation rates across that time. This research was really interesting, but kind of to do that kind of measurement method in an occupied home is quite invasive for the occupants. It's there's a lot of equipment needed, and it's, you know, obviously it's a long time to have that equipment installed in the house. So for this study, that took place in one of the researchers' homes. So that obviously means that they have probably quite a lot more tolerance for measurement equipment than maybe your average person would do. So I was kind of interested in that though, because you know, they were finding this quite variable ventilation rate, which other kinds of research that I was looking at typically wasn't talking about how the ventilation was varying in quite the same way. So one of the alternatives, so in that research I just talked about, they used SF6 decays, but you can use CO2 as well as a tracer gas, and probably most people are quite familiar with the decay method, but I'll just go over it quickly. So the idea with this is that you can raise the CO2 concentration in a space and then let it decay back down towards background values, and that'll produce kind of an exponential decay. And the decay constant tells you the ventilation rate. So that's quite a nice method that can be used. There are kind of two options with that. One is to raise the CO2 concentration by artificial means, so by releasing gas into the space. And another option is to use metabolic CO2, so that's CO2 that people are just breathing out. One of there are advantages of using metabolic CO2 in that it's kind of requires less invasive equipment than if you were going to release the gas from kind of a controlled source. It's cheaper because you don't need to you know, bring the gas in and release it in a controlled way. And another advantage obviously is that you're not releasing additional CO2 into the atmosphere or any other gas that occupants might be kind of concerned about. This gas would obviously just be naturally there. So what I did was one of the problems with applying the CO2 decay method in occupied homes is that it can be challenging to identify when the space is unoccupied, which you need because obviously otherwise people are continuing to breathe out CO2, and so that you're not going to get that nice decay. So it can be challenging to identify when a space is unoccupied in a kind of robust and repeatable manner. Typically what you see in ventilation research where they've done CO2 decays is that they might rely on occupant diaries, or they might assume times when people aren't going to be present, or they might sort of hand pick periods of the data when you can see that occupants aren't present. And these are all fine, but it does mean that for kind of extended monitoring periods, those options can become quite sort of labor intensive, and yeah, not, you know, that which isn't great really. So one of the things that I did was to develop a occupancy algorithm. So this kind of looked at the data that I was collecting and kind of determined whether or not it was likely that the space was occupied or not. So that's what you can see in this plot. I don't know if you can see my mouse or not, but the kind of light gray periods are times when the algorithm thinks that there are probably people present in the home, and the darker gray periods are times when it thinks that there aren't people at home. So it's doing this using both the CO2 measurements, which are obviously required anyway for the method. So those measurements were being taken anyway, and using door and window opening data, which is what you can see on the bottom panel. That's the different doors and windows in the space and when they're being opened and closed. So I also measured the front door, you can see is on the bottom panel as well. So between times when the front door closed and when it next opened, the algorithm kind of looks at the data between those periods and asks, okay, did any of the doors or windows change position, because then I think someone's there. Or alternatively, if none of the doors or windows change positions, did the CO2 concentration rise, in which case it's likely that someone is present. So that, by developing that algorithm, it kind of allowed me to kind of collect a lot of data and then pass that over to the algorithm for it to kind of tell me, okay, I think that the space is unoccupied during these times. And then once I had those kind of unoccupied periods, we could then look at, developed another algorithm to identify periods of decaying CO2, which is what you can see in the kind of the black periods in the top plot. So that's where the CO2 concentration is sort of decaying, and we think that that's a reasonable period of data to use for a concentration decay ventilation measurement. And so by kind of combining those two algorithms, I was kind of able to collect all of this data and then use the two algorithms to generate a lot of ventilation measurements over kind of an extended monitoring period. So that kind of helped to be able to assess the variability over time. This is to remind me to plug that we have a paper kind of describing this, these algorithms that we developed. Yeah, so that's in the Journal of Building Pathology and Adaptation. That also links to my GitHub, where we put the Python code for those algorithms as well. So that's kind of freely available. If anyone's interested in applying these methods in kind of their own research, then that code is available. And I'd also be really happy to chat to anyone who was interested in using it. So yeah, that's just a reminder to plug that. Okay, so yeah, so moving on to kind of now that we could measure the variability in ventilation, what kinds of things did we actually measure? So I looked at two case studies. The first was an unoccupied test house. That kind of let me test out the method and also kind of explore the use of trickle vents in single room versus whole house ventilation rates. And the second was 4 occupied flats. They were fairly, well, the building was built in the 80s, and then these flats then was converted to flats in 2015, I think. These were like fairly small flats, 1 or 2 occupants, and they had a sort of continuous MEV system. So I will get onto the occupied flats later, but I'll talk about the unoccupied case first. Yeah, so this is a 1930s building, cavity wall, suspended timber floor, semi-detached test dwelling. It had been retrofitted throughout with double glazing and trickle vents, but it had no mechanical ventilation. It's quite high air permeability, about 15 meters cubed per hour per meter squared. So it's quite leaky by sort of modern standards, although fairly typical of its age. And yeah, so I set up the CO2 sensors, had sensors in each of the rooms. Some rooms have multiple sensors, so I could look at sort of distribution of CO2 as well. And we also had a CO2 sensor outdoors as well to measure the concentration that would be decaying towards. Oh, so yeah, so what I was doing was in the, I wasn't sure what to call this room, so I just called it the back room on that figure on the bottom left. I was closing the door to that room and then raising the CO2 rate either by myself or using controlled releases, and then going away and either leaving the trickle vents opened or closed. And I did that lots of times, I think over 40 times in each configuration, so that I could look at how the ventilation rate was varying in that space. And we also did some whole house experiments as well, where we released CO2 in the whole house and looked at the decay there as well. So these were the kind of results of that. So I mentioned the permeability was quite high. The whole dwelling ventilation rates were also pretty high. So with the trickle vents open in the whole house, it's about 0.8 air changes per hour. With the trickle vents closed, about 0.6. when we looked only in the back room though, so that's where we just were raising the CO2 in that room at the back and letting that decay with the door closed, the ventilation rates were much, much lower. So with the trickle vents open in that room, the average was about 0.3 air changes per hour. And with the trickle vents closed, the average was about 0.2 air changes per hour. So obviously it's a quite significant difference between the single room ventilation rate and the whole dwelling ventilation rate, which, you know, depending on how people are living in the space, could be quite significant for the kind of air quality that they experience and whether or not they, you know, have good ventilation rates in the spaces that they're occupying. Let me just check if I wanted to say anything else about that. Sorry. Yeah. Okay. Yeah, that's fine. So, okay, and then I think that was one of the key findings from the unoccupied house. And then moving on to kind of the occupied cases. These were these 4 flats in London. 2 of them were studio flats, 2 of them were 1-bedroom flats. 3 of them were on the ground floor, 1 of them was on the first floor. They had a continuous MEV system with trickle vents. So that's system 3, as referred to in ADF. And the way that that's supposed to work is that the trickle vents are supposed to be open, mechanical ventilation is supposed to be switched on, and there's supposed to be a continuous low level extraction of air from the wet rooms, so the kitchens, bathroom and the utility rooms. And then there's supposed to be some allowance for a high flow rate or a boost extract rate when there are things like people showering or using the bathroom or cooking or so on. When there's high pollution events, there's supposed to be this boosted flow rate that's available at those times. So the flats were monitored between June 2019 and January 2020, so just slipping in there before COVID. And we did quite a few types of measurements there. So did this ventilation measurement using the CO2 decays I talked about already. We measured the window and door opening as well. We did indoor air quality monitoring in the kitchens. We did fan flow measurements of the extract fans in the kitchen, bathroom and utilities. I also did semi-structured interviews with the participants at the end of the monitoring period. And in 3 of the 4 dwellings, I also did air permeability tests. And in 1 of them, we did thermal imaging during depressurization to kind of have a look at the leakage paths. So yes, that's the data we were collecting. And then just to go over some of the kind of, hopefully some of the kind of most interesting results. So yeah, so one of the things that was quite striking was, so according to ADF, the extract fans had kind of a stipulated flow rate that they were supposed to meet. So the total flow rate across all the fans in the flats was supposed to reach 13 litres per second. Oh, I haven't got my units on there, sorry. On the left, that's litres per second, and on the right, that's air changes per hour for the same measurements. So yeah, so according to ADF, we should have 13 litres per second, a whole dwelling flow through the fans. When we actually measured the fan flow rates, they were much, much higher in all of the flats. And there was also no apparent boost rate. So it didn't matter what we did, the fans were always extracting at this rate constantly. So flat A, you can see the total fan flow rate was about 30 litres per second, whereas ADF requires 13. And then for the other flats, still significantly above the 13 litres per second required. And then on the right, I'm just converting those numbers into air changes per hour. So then, having looked at the fan flow rates, we looked at sort of comparing them to the ventilation rate measurements we were getting from the CO2 decays. And this is what we got. So yeah, so despite having really high fan flow rates, the actual measured ventilation rates in these spaces was actually quite low in comparison. And just to be clear, these measured whole dwelling ventilation rates are the median of the ventilation rates I measured with the windows closed. So yeah, so this is quite striking, I think, how different these numbers are. Oh, I should say in flat A, it wasn't possible to measure the whole dwelling ventilation rate because those occupants, almost whenever they left the building, they opened at least one window. So I think 98% of time in flat A, 98% of the unoccupied time, they had at least one window open. So they pretty much, whenever they left the house, they would open a window. So it wasn't possible to measure a ventilation rate for that building. But for the rest of them, we can see that the measured whole dwelling ventilation rate is a lot lower than the ADF requirement and suggested what is suggested by the total fan flow rate. I should also say that flat B, the ventilation system was switched off throughout the entire monitoring period. Might get onto this later, but that occupant just was not aware that there was a ventilation system at all. They kind of knew that there was an isolation switch in the utility cupboard, but they didn't know that that controlled the ventilation system, and they didn't think they'd ever touched it. So yeah, so their ventilation system was off, which is partly explains why their ventilation rate was so much lower than the other two, although C and D still have lower than we would kind of hope. Okay. Yeah. So, so just one other thing that came out of doing these fan flow measurements in these houses. So flat C, in the bathroom, when I came to do the measurements, I had to take a step ladder. So I'm only 5'2", so I couldn't reach without a step ladder. And when I brought these step ladders in, and he saw me kind of getting on them to measure the flow rates through these terminals, he said, "Oh, when you're done, can I just clean off? I've noticed the one in the terminal in the bathroom is quite dusty. I'd really like to clean that off when using your steps, if you don't mind." So that's fine, obviously. So I measured it before the flow rate through the terminal before he did the cleaning, and then again after he did the cleaning. And that more than doubled the flow rate through that extract terminal. Either just because of the amount of dust that had built up, it was quite visible. You could see it, and I didn't manage to get a picture of it before he cleaned it, which was a bit gutting. But nonetheless, yeah. So it's either from just cleaning the dust away, or it's possible that he slightly, adjusted the aperture when he was doing the cleaning as well. But either way, I think it's quite striking how much difference that made to the flow rate through that terminal. Okay, so this is a bit more on the ventilation rates themselves. So this is just summarizing for each of the flats what the distribution of ventilation rates I measured was in each of the configurations of doors and windows. So I'll just explain that, probably a bit much information. So the first plot on the first box on the left is for flat A. It seems to have lost its label at the bottom, at least for me. Anyway, that's for flat A, and that's with 2 of the windows open in the living room, bedroom window open, and all of the doors in the flat open. So that's all of the measurements of ventilation rate I measured in that configuration of doors and windows. There's 20 of those, and you can see the spread in that over time. And then each of these boxes going along is a different configuration of doors and windows, and kind of the spread of ventilation rates that we see with that configuration. So yeah, so one thing that's notable, so flat B that I mentioned had the ventilation switched off. That's the kind of bluish and greenish boxes on the left. They've got quite a small kind of spread in their ventilation rates over time in those two configurations, which are both with, oh well, the blue one is with one window open and the green one is with none of the windows open. And then the other three green configurations are flat C and D with all of the windows closed. So this is kind of, when I gave the median result earlier on, this is kind of the spread of results associated with that median. So we can see that with the windows closed, even in the flats which have the ventilation system on, the majority of the measurements are still below that kind of 0.5 air changes per hour threshold that we would kind of hope to see, ideally, although some of them go above that. And then obviously the cases with the windows open, oh sorry, I've had helpful things to tell me which ones I was talking about, but anyway, the ones with the windows open, which the ones that are not circled now, they are the cases with windows open, and you can see that they have a much higher spread in ventilation rate, obviously, which is probably what we would expect. Okay, and then what we could start doing, because we are measuring so many ventilation rates over time in various different configurations of the doors and the windows, we could start to look at whether or not the conditions in which we were measuring the ventilation rates, whether or not they match the conditions during occupied times. So, for example, the top row of plots there is, this is for flat B, the top row of plots there is for none of the windows open and all of the doors open in flat B. And the plot on the left-hand side with decays unoccupied, occupied, that's showing the proportion of time, well, the occupied and unoccupied is showing the proportion of time that the dwelling spent in that configuration during occupied and unoccupied times. So when that flat was unoccupied, about sort of, was that about 45% of the time that it was unoccupied, none of the windows were open and all of the doors were open. And then a bit less than that, about sort of 35% of the time maybe, when the flat was occupied, it was in that configuration with no doors open, no windows open, all the doors open. And then the decays, that's what proportion of the decays that I measured were in that configuration, and so on. So then the subsequent rows also show the other configurations of doors and windows. And then the next plot over, the second one, shows the distribution of ventilation rates that we measured in that configuration. And then the plot in the middle is showing the temperature difference during measurement times. So that's the greenish color, and during occupied times, which is like the purplish color. And so we can see, like for this top plot, for example, there's the spread and kind of distribution of temperature differences during measurement times is quite similar to the spread of temperature differences that we see in occupied conditions. So kind of suggesting that the spread in ventilation rates that we're measuring probably is going to be, sort of similar to the conditions that the occupant might actually be experiencing. Yeah, because obviously one of the kind of tricky things about CO2 decay is that you require that the occupants aren't present during the measurement time. So although we're kind of interested in the ventilation rate the occupants might be experiencing, the measurement method is such that we can't directly measure it while they actually are there. So this is just a way to kind of say, okay, were the conditions that we measured in actually similar to what we think the participants might actually be experiencing when they are there. So yes, I think that was quite useful to be able to start doing that. Yeah, sorry, I was just checking if I needed to say anything else there. Oh, the p values you can see on those plots are just p values from using a Mann-Whitney U-test to compare the distributions during occupied times and unoccupied and measurement times. Yeah. Okay, so that was kind of like a whistle-stop tour of my kind of like technical exploration of ventilation rates in these homes. kind of trying to pick out the most interesting bits and kind of discuss those more. I'm going to talk a bit about the kind of the socio-technical side of the research now. So I think typically what we see in ventilation research is that there's been, sometimes there's some consideration of the social element, the social dimension of what's going on in homes or in buildings, but it's often not as detailed as the kind of technical measurements we might do. We don't often get the kind of the same depth as we might get in the technical domain. But at the same time, occupants obviously have a really important role in determining the ventilation conditions in their homes. So both from the sense of sort of how they control the equipment, so what they do with trickle vents and windows and fans and so on, but also in terms of how much ventilation is needed as well. So occupants obviously are affecting the conditions that are present in the home in that sense as well. So one thing that's been quite often used in sort of research in buildings, in sort of an energy research in buildings in a kind of general sense, is the use of social practice theory to kind of bring social and technical realms together, if you like. So I'm not going to go too much into the kind of detail of social practice theory, but just to give a kind of brief overview, social practice theory is a theory from sociology that places kind of significant emphasis on what it is that people are actually doing, so their actions and their doings and their sayings, and how they are affected by sort of rules or knowledge that they might have, and what kinds of aims people have, what kind of people are actually trying to do when they're taking particular actions. And also social practice theory in particular is quite good because it has often been used in a way to place significant emphasis on the technical domain as well. So kind of how people are interacting with actual physical things in order to kind of achieve the kind of aims and goals that they have for whatever it is that they're doing. Yeah, okay, so the kind of premise of the final part of the work was to compare the intended use of ventilation systems according to ADF with the occupants' ventilation practices. So I was interested in ADF because this sets out these systems which are supposed to provide adequate ventilation in homes. But I mentioned right at the beginning that actually research that does exist has often shown that ventilation equipment actually isn't used in the ways that it was designed to, or the way that it was kind of intended to be used. And that can, cause a problem for whether or not then the ventilation is as kind of we might have expected. So ADF kind of splits ventilation into 3 different types. So they've got whole dwelling ventilation, extract ventilation, and purge ventilation. And I am aware ADF has been updated since I was doing this research, but this kind of structure I think is still present in the system, so I think it's still relevant. And then for each of these types of ventilation, there's kind of a specific purpose associated with the type of ventilation, and there's kind of the equipment which is supposed to provide that type of ventilation is also set out quite clearly. So I'm going to go through each of these types of ventilation in just give kind of a summary of what I found related to the participants and what they were doing in terms of these types of ventilation. But just to kind of say at the beginning, ADF is not written, obviously ADF is a technical document, but it does have kind of got implicitly the occupants are present in the document, in the sense that although it's not kind of explicitly saying who's taking particular actions, it's assuming or kind of suggesting that things like the trickle vents will be kept open, the MEV will be kept on, windows will be opened in particular circumstances when there are high pollutant loads and so on. So the occupants are kind of implicitly involved, I suppose, in the kind of system that ADF is setting out. Okay, so yeah, so I'm just going to go through each of the types of ventilation and kind of summarize. So whole dwelling ventilation, according to ADF, is for it's kind of continuous ventilation to remove residual pollutants and to provide fresh air for breathing. So the participants, I think, they broadly had aims and goals which kind of aligned with that ADF purpose. So they were kind of keen, they would talk about wanting to have fresh air in the home, which had been circulated, it wasn't sitting still, it wasn't stagnant and stuffy. So one thing, it's often easier, I think, especially with indoor air quality, to talk about, sometimes easier to talk about the opposite of good indoor air quality than talking about good indoor air quality itself. So people might be more able to talk about sort of bad indoor air quality than good indoor air quality. But nonetheless, the participants kind of had this kind of sense of wanting fresh and circulated air in a way that might kind of mirror that ADF purpose broadly. So for ADF, that kind of ventilation is provided by the mechanical extract ventilation system in its low flow mode and open trickle vents. And ADF kind of says trickle vents can be closed in exceptional circumstances. But for the occupants, when they would talk about having fresh air and circulating the air and kind of moving the air, they would really be talking about that with reference to opening windows. Some of the participants had some kind of feeling that the MEV system should be doing something to help with kind of circulating the air, but that was quite difficult for them to articulate and difficult for them to identify that that's what it was doing as well. So if ever they felt that they needed to kind of circulate the air, then the windows would be what they would use. They also, all of the participants had the trickle vents closed on all of the occasions that I visited the dwellings. So that was between 4 and 6 times over 6 months. They were always closed on each visit. We did the interviews at the end, so I wasn't kind of influencing what they were doing by talking to them about it during the monitoring period. And several of them were not aware that they had trickle vents. Some of them were aware that they were there, but kind of didn't feel that they kind of provided anything additional, so they wouldn't open them. The only kind of times when people would have tended to open them, those who were aware what they were and ever used them, they kind of talked about using them at times when sort of security concerns intersected with feeling that additional fresh air was required. So one of them talked about opening them when they would, if they, for example, if they had done a load of washing and it was drying, but they were going out for the day and they needed to ensure there was extra air to kind of help dry the clothes. And they wouldn't have wanted to leave the windows open for kind of security concerns. And another one, I think, talked about opening them sometimes when they went away on holiday. But yeah, so that's almost kind of the opposite of what ADF is kind of, or what the plan system is kind of hoping for, in that for participants, trickle vents are opened in exceptional circumstances when something happens, whereas for ADF, trickle vents should be closed in exceptional circumstances. So there's just kind of a misalignment there. And also the participants kind of, even the ones that would talk about the MEV system and kind of assuming or hoping that that would do something to do with circulating the air, that wouldn't then also be connected with the trickle vents. There was no kind of idea that, you know, the trickle vents need to be open for the MEV system to work. Yeah, and the other thing to mention as well about this kind of background ventilation is for ADF, you know, pollutants are dissipated by ventilation, but for the occupants, they could also, their other option for dissipating pollutants, particularly odor, was to use air fresheners. So one of the participants, for example, they had a pet dog and they were quite concerned that their house might smell like dog, and they were, you know, concerned that people would come over and think that the house was smelly, basically. So they would use air freshener to try and counteract that. That's kind of interesting because, you know, from a kind of technical perspective, you've then got two pollutants, and that you've got the dog odor that you want to get rid of, and you've also got the air freshener kind of pollutants and VOCs associated with that. Whereas from the occupant's perspective, the two have kind of cancelled each other out. Oh yeah. Okay, and then extract ventilation. So for ADF, this is kind of extract ventilation is to do with kind of removal of regular or expected high pollution loads in specific locations. So like particularly cooking and showering and so on. And so the participants broadly wanted to be able to do this kind of thing as well. So they were keen to confine smells or steam associated with particular activities to the locations in which they were emitted, and they were keen to kind of limit the extent to which those kinds of pollutants spread around the house. But they would do it using quite different technology. So they would talk about, you know, perhaps when they were cooking, like wanting to, like, they would talk about closing doors to make sure that that smell would stay in the kitchen and not spread through to the rest of the house. Or they would talk about similar things with the bathroom as well, closing the door to keep kind of steam from escaping. Yeah, whereas so that's what the participants would be doing. For ADF, the extract ventilation should be provided by the MEV in high flow mode and open trickle vents. And again, just worth saying, these flats actually didn't have the high flow mode, the MEV. That just didn't seem to be something that the system would do. So yes, their system was actually always operating in continuous sort of low flow mode. Although even if the flats had high flow modes of boost flow rates, and in their ventilation plans, there was kind of no way for the occupants to directly switch the system into the high flow mode themselves. So it would have only been humidity controlled according to the plans. So yeah, so again here, I think the participants broadly have kind of similar aims to ADF, in that they do want to confine high pollutant loads to specific locations and make sure they're extracted from that point, but they don't have the high flow MEV available to them, and they tend to use technologies like windows, doors, or particularly the cooker hoods in the kitchens. Okay, and then finally, purge ventilation. So for ADF, this is kind of removal of one-off high pollution events anywhere in the dwelling. And that can be provided in ADF either with windows being open by more than 15 degrees or by the high flow rate from MEV if there weren't windows. These flats didn't have windows in the bathrooms, so there was kind of no option actually for purge ventilation in the bathrooms. But again, the participants kind of broadly, they were keen when something kind of unexpected happened, like burning toast or something like that, they were keen to very quickly dissipate the pollution associated with that, or the smells associated with that. But they would also, there were also cases where they almost had the kind of the opposite situation happening, in that one of the participants lived close to the front door of the building, and he would find that people would smoke outside his flat. And when that would happen, he would kind of go over to his window and kind of slam it shut, both to, he said, like both to kind of express his frustration and kind of hope that the smokers would like move further away from the building, and also to kind of limit the ingress of the smoke into his house. That's almost like an anti-purge, if you like. It's almost the opposite of purge ventilation. Like the indoor environment then is kind of a reservoir of unpolluted air, and they need to kind of make sure that it's sealed off almost from the outdoor lower sort of poor air quality environment. Yeah, also for these participants, even when they would do purge ventilation with the windows, or would ventilate or would open the windows in circumstances in which ADF would consider purge ventilation to be appropriate, they would always open the windows just by tipping them. So they had like tilt and turn windows, so they could open them either just by sort of tipping them inwards, or they could open them sort of fully, you know, like a door. But they would pretty much, all of them would only ever tip the windows open. And that was for a number of reasons, partly to do with security concerns. Yeah, or a lot to do with security concerns, but also kind of wanting to keep kind of rain and wind and so on more out of the building. The couple with the dog also were keen to not let the dog jump out of the window. So yeah, so a number of reasons that actually doing purge ventilation as kind of opening the window kind of fully was actually not really practical in these buildings. Also because the windows opened inwards, sometimes it would mean some kind of like rearrangement of the furniture, which just meant that it wasn't really practical to ventilate in that way. Okay, so I'm just going to go over some common themes. Oh yeah, I'll do that quickly, so hopefully we've got some time for some questions. So yeah, so common themes. So I think broadly, I think the participants actually had similar aims or goals to the kind of purposes of the different types of ventilation in ADF. I think that's quite hopeful, really, because it kind of, I think often with ventilation research, it's kind of easy to think that, oh, participants or occupants aren't really, they don't really think about ventilation in the same way we do. Like, it's not something that they're kind of worried about and so on. But actually, I think this kind of suggests that there are lots of ways that participants are thinking about ventilation in the air in their homes, and there are kind of ideas that we might be able to kind of latch onto or kind of use in kind of designing systems that might be more intuitive or more easily used by occupants. So I think that's quite hopeful, really. The participants' approach is much more contextual, so they don't just pay attention to kind of pollutants in the air, but they're also interested in like temperature, noises, kind of the conditions outside and so on. They use equipment really differently than the way ADF kind of sets out, in that they are much more in the technologies that they are familiar with are really windows, doors, and sort of cooker hoods. And the kind of ventilation systems set out by ADF are much more in the background, something that they don't interact with and know they have to use in a specific way. Yeah, so participants don't always have the same expectations regarding what is and is not a pollutant. This is kind of coming back to the idea of the dog and the air freshener, for example. Oh, and something that I didn't really mention before, these participants didn't really have an expectation that maintenance of the MEV and trickle vents is required. None of them that was not something that they were kind of considered, not something they were sort of planning to do. I think that's quite important as well for a kind of like future research direction, in that, you know, we've got lots of these ventilation systems of all kinds of different ones installed in people's houses, and if they're not being maintained appropriately, then they might well not be performing as well as they could be. So yeah. I'll just say something really quick about this. So yeah, so just to summarize, measurement of ventilation in homes can be challenging, especially to measure the variability over time. And yeah, the adequacy of ventilation can vary over time and depending on the setup as well. So we got around this using CO2 decay method with some algorithms to identify occupied and unoccupied times, to kind of help us be able to measure ventilation over time. And also, yeah, occupants and kind of what's going on with ventilation in homes, kind of quite a nuanced relationship, I think, that requires more research to kind of identify ways that we might be able to produce ventilation systems that are more likely to be used in the way that, you know, in the intended manner and result in sort of adequate ventilation. I will stop there, so there's some time for questions.
Brilliant, thank you very much. That was really interesting, really good. So yeah, we do have a little bit of time for questions, if anybody has any. If you just want to either put them in, yeah, if you put them in the chat or stick your hand up. So yeah, there's one from Jenny Briley. Jenny, do you want to read it out, or do you want me to read it out?
You can read it.
Okay, so Jenny's question is, were the occupants concerned about heat loss, and did that affect how they ventilated their homes?
Yes, so for some of them, yeah, I think so. So for one of the sets of occupants, they had their windows open a lot. They were concerned about the smell from the dog, and also they just felt that it was quite sort of healthy to have a kind of circulation of air. But they said they would really rather just put on an extra jumper than close the window. And they also said for them, they lived in these block of flats, and they found that kind of they would be sort of passively heated from the buildings, either side and below them. So they found that they didn't have to run their heating very much. So yes, they weren't really concerned about losing the heat, because they felt like they didn't use the heating very much anyway. Other participants, would close the windows much more in the winter, and sort of would, there would be times when there would be sort of a conflict between the pollution in the pollution that they were sensing in the dwelling, and wanting to have the windows open to disperse that, but also just being freezing cold. So yeah, that definitely did affect what some of them were doing. Yeah. One of them, actually quite interesting, had previously lived in a house that overheated a lot, or they felt that it overheated a lot. And there they had consistently left their trickle vents open, because they felt that they needed some kind of passive flow of air. But on moving to this house, they found the house was quite cold, and they actually hadn't even noticed that they had trickle vents in this house. So, yeah, bit of all sorts going on, really.
Thanks. That's really interesting, particularly as people can feel when they're hot and cold, but they can't necessarily tell what the air quality is like. So if people are making decisions about ventilation based on heat, they're unaware of what it's doing to the air quality. So I think that's really interesting that you were measuring that. Thank you.
It is interesting in that the things which were perceptual were the very perceptual things, like burnt toast. Your nose is a useful thing, but it only detects the things in extremis. I've got a couple of questions. So there's a hand up, Tuan Vu. Forgive me if I've not pronounced that correctly.
Hi, hello. Yeah, you pronounced correctly. Can you hear me?
Yes, we can.
All right. Yeah. Thank Jessica for really nice talk. So, I just wonder about the ventilation measurement by the CODK. So, how about the uncertainty of that methods? I mean, do you find any like the impact of the outdoor CO2? And another question is, have you ever investigated the impact of the outdoor climate, like the wind speed or the rain, onto the ventilation rate? Thank you.
Yeah. So in terms of the uncertainty, we looked at that in two different ways. So firstly, because I was measuring the CO2 in more than one location in each of the flats, so I was able to kind of look at the spread of CO2 in the building, and look at kind of the effect that the kind of any inhomogeneity in CO2 had on the measured ventilation rates. So that was one aspect of the uncertainty. Another one was kind of the accuracy of the measurement of CO2 itself. And we looked at that using periods of co-location data. So I would put all of the sensors together for an extended period of time, and look at how variable the measurement of CO2 was over time. And so by doing that, I was able to kind of come up with an estimate of the uncertainty associated with the measurements. Off the top of my head, the uncertainty would be around about sort of 8%, I think, of the measured ventilation rate. But that would vary. That would be kind of like the mean uncertainty. It would vary depending on the particular period I was analysing. And also a really nice point you made about the effect of the outdoor CO2. So we did see that the outdoor CO2 can be actually really highly variable. and that can affect the measurement a lot. So what we ended up doing was we placed some requirements on how much we allowed the outdoor CO2 to vary in the period of the measurement and in the period immediately preceding the measurement. So at times when the outdoor CO2 was varying a lot, we didn't take CO2 measurements during those times because it's just it's quite uncertain. Hopefully that answers a bit about uncertainty. And then in terms of looking at the effect of the weather conditions, we did do that. It was quite possible to build quite a nice model of the ventilation rate with the weather conditions for the unoccupied house. So we've got a model that worked quite well for them. For the occupied ones, the models didn't really work very well. I think that might be because these flats were in London. We were taking the wind from Heathrow, it's about 20 miles away, and it's quite an urban environment, obviously. So I think the wind probably was not very representative. The wind measurements we had probably were not very representative of the wind conditions at the site that we were actually measuring the ventilation rates. So yeah, so hopefully that makes sense.
Right, thanks. There's a couple of other questions in the chat. So one is it's saying whether you saw spatial distribution of CO2 within individual rooms, and the other bit of that question is, could you see sort of CO2 events in other rooms?
Well, for the dwellings, the occupied dwellings that we were measuring, we had one CO2 sensor per room, and we would require that they were in a certain level of agreement in order to kind of take a decay measurement over the period. What we did see in the occupied flats in one case was that just by luck, two of the flats were next door to each other. And there was a time when one of the flats was unoccupied, the other flat became occupied, and we could see that the CO2 from the occupied flat was actually leaking into the unoccupied flat next door. So yeah, which is not great, obviously, in terms of keeping spaces separated, but also yeah, has some implications as well for kind of what we can say about the measurement.
Right, thanks.
Yeah.
And there's one other question. Yeah, so it's saying that decay's probably assuming a well-mixed room. Did you try any of the Firefield or multi-compartment models for estimate of air change rates?
No, we did only use single zone models. As I said, we measured in more than one location in the room to try and make sure that the CO2 was the CO2 that we were measuring in those two spaces indicated that the CO2 was kind of reasonably well mixed. Yeah.
Okay, grand. Okay, fine. Well, we're nearly out of time. So that was really interesting. I mean, there's so much in that stuff. I mean, I think a lot of these things, a lot of considered ventilation is focused a lot around the technical things, and often they're about sort of professional standards and protection from the liability. I think there's a slight tendency that sometimes we forget that buildings are for people and we need to design them to be used. And the maintenance thing, I think, is particularly interesting. You know, that thing about cleaning, what will happen almost inevitably, in order to clean a device like that, you will unscrew it slightly in order to get your hand in to clean it. So, you know, I don't know what that does to commissioning and so on. So I think that's really interesting. So listen, we'll wrap up there. Thank you very much, Jess, for that fantastic presentation. Good to see you again. And we've got other talks coming up, but if you keep an eye on the Breathing City website, we'll see where they come.